All right, and we'll go from current slide. And what I also meant to take with me was the flash drive, because I need it for my next class. I don't need it for this one. And I'm afraid I'll pick up the computer and break the flash drive if I don't, not paying attention to it. And it might also help if I not to get. I don't know. The old gray cells aren't working too well. Okay. As soon as we get some visibility here. It is flashing, but I sure don't see much there. I see a little bit. The board being so dirty, it's kind of hard to see where the light is. All right. Now I have a strange notation here. It seems like we were working on example 10, chapter 4, higher order differential equations. 4.4 is undetermined coefficients superposition approach. Page 149, example 10 was a third order differential equation, case 1. And I know we got started on that, but it seems like to me we hadn't quite finished it. And I said, are y'all going to want to work on that yourselves? And I think Josh said, oh, we can finish that.
That's what Josh said.
That's what Josh said. Okay. That's where I was thinking. Within 5 minutes of the class being over, I said, wait a minute. I did something really stupid there. So let's go on and just quickly reproduce what we did, just so we'll know where we are. Let me get my pen set up. Y triple prime plus y double prime is equal to e to the x cosine x. I have such a mess up there. Let me see if I can clean it up a little. Whoa. Okay. That's a lot better. Not completely, but all right. Okay, our auxiliary equation that we did before was m cubed plus m squared equals 0. And that gave us m squared times m plus 1 equals 0. So m equals 0 is a double root. And, yeah, and m equal minus 1 is a single root, okay? I'm going to put double root, okay? Yeah, m equals 0, m equals 0, yeah. Okay, double root. I'm going to try another one. Didn't do much. Well, actually, overall, it may have helped. But right at first, it didn't seem to do any good at all. Just got one more 2-hour class after this one. Wednesday is somewhat of a long day. Okay. Now, so our complementary solution, y sub c, is equal to c1 e to the 0th x, which is just c1. But because it's a double root, we have a c2 x e to the 0th x, which is 1. Okay? And then our other plus c3, and this is e to the minus x. Okay. Now, thinking a lucky stars that that's not a minus x up there. If it was, then we'd have to do something else stop, that's the plus x, this is the minus x. Okay. Particular solution. Y sub p, we came up with what we thought it was. Do you remember what it was? A oh, I left off part of the problem, didn't I? Cosine x, I didn't write my x in there. Okay. What's our particular solution?
ax plus b plus cx cosine theta.
Okay. Did I hear a e to the x cosine x plus b e to the x sine x? Okay. All right. What we do from there is take a derivative. Y prime, yp prime. And this is going to have multiple parts. Which way? I like to do derivative of the first in this case. Now here my computer is not charging again. And I do not know why. It just, the light went off and is not even flickering now. And I didn't touch a thing, I didn't do a thing that I know of. Nothing. Nothing. It's just like the plug's not working anymore. There it is. It's only in this room that it does this kind of stuff. I hope it'll keep going. It's slightly blue. Okay, sorry about that. So, I'm going to do derivative of the first, which would be a e to the x times cosine x, plus the first, a e to the x, times derivative of cosine x, which makes that a minus sine x. Okay. Now let's do the same thing for the second one, and that'll be a plus b e to the x sine x plus b e to the x cosine x. Okay. Nothing here that you can really combine, so let's just proceed. Y particular double prime, which we're going to need. We got this one to do over again, which is going to be just like it was before. So that's a e to the cosine x minus a e x. E to the x, left off my x there too, sine x. Okay, that's the first term integrated. Now let's do the second one. Minus an a e to the x sine x minus an a e to the x cosine x. Agreed? Okay. Looks like my battery just quit again. Or the computer quit charging the battery, or recognizing it had a battery, or whatever. Like I wasn't plugged in. All right. Got the first two done. Now let's do the next one. I'm going to write it underneath it because I don't have room. B e to the x sine x plus b e to the x cosine x plus b e to the x cosine x minus b e to the x.
What you say on the second term, you doing b e to the x cosine x?
Yeah.
Where's the minus?
Huh?
Where's the minus?
Okay. I'm doing the derivative of the first times the second. And here's going to be my minus.
Okay.
Minus, yeah. I do that because I just like to lead with the plus and follow with the minus. It's just a dumb thing of mine. Sine x. Now, this one will simplify somewhat. Here's an a e to the x cosine x and a minus a e to the x cosine x. And here's two of these. So this is actually, well, we'll come back and do that. Here's a b e to the x sine x and a minus b e to the x sine x. Those go to 0. So this y double prime, y particular double prime is, I'm going to lead with the positives first again, 2b e to the x cosine x minus 2a e to the x sine x. Okay to do it that way? Yeah. Here's what I did. These two went out, but, huh?
I need the two. You have two minus.
Right.
Minus two.
And that's
A
minus
e to
2
the x,
a e to the sine x.
sine x.
And then plus 2, I just swapped them because I like to lead off with the plus. It's just a dumb thing. Okay. Now, let's do y particular triple prime, which is just a derivative of that. Okay? Again, I'm going to lead with the positive. 2b e to the x cosine x minus 2b e to the x sine x. Right? And then we have minus 2a e to the x sine x minus 2a e to the x cosine x. Okay. Now, for that super long equation, it's y triple prime, which is the thing we just wrote, so I'm going to start it way over here. 2b e to the x cosine x minus 2b e to the x sine x minus 2a e to the x sine x minus 2a e to the x cosine x. That's y triple prime. Plus y double prime, which is the line just above it, which is plus 2b e to the x cosine x, aggravating, minus 2a e to the x sine x. Okay? And evidently all that's supposed to equal e to the x cosine x. Right? All that line above it equals it. Now, let's see if there's anything else we can eliminate or do anything else with. Here's 2be to the x cosine x twice, so that's going to give us 4 of those. And 2 minuses here are going to give us 4 of those. So I can cut down the length of this a little bit. This one and that one combined to be 4be to the x cosine x. And this is the one and only minus 2be to the x sine x. Okay? Minus, I'll wipe that one out too now. We got 2 of these, so that'll be minus 4a to the x sine x. And then we've got just minus 2a to the x cosine x. Okay, and that's supposed to equal e to the x cosine x. Now, in order for that to be true, and here's where I made the dumb mistake, I don't even know why. All right? Let's identify our e to the x's with a trig function. Here we have an e to the x cosine x, and we have one over here too. Okay? So that's going to be a 4b. Here's another minus 2a. Those are your 2 terms with cosine x, e to the x cosine x, right? That's got to equal 1.
I don't see the,
I'm sorry?
I don't see the A component.
Okay, say that one more time. Here's a e to the x cosine x. Here's an e to the x cosine x. That's 4b minus 2a. And over here's the e to the x cosine x. That must equal 1. So 4b minus 2a is equal to 1. Okay? All right. Now, let's look at our e to the x's sine x's. That's preceded by a minus 2b minus 4a, and we have no e to the x sine x's over there, so that means that's equal to 0, right? Okay? You agree? All right. Now, this gives us 2 equations, 2 unknowns. The trouble is I don't have any room left. So I'm going to have to come up here and start erasing something. Is it all right to start with my y particular? So I'll erase this, and this, now that may be enough to get me going, but frankly I think I'm going to need the next line too, so let's go and erase that too. And that was followed by this one. And nothing's erasing now. All right, I think I've wiped out enough. Okay, now, let's write okay, nah. So what we have are 2 equations, 2 unknowns. I'm going to write them the way I've got them. It's sort of dumb. I don't know why my pen just suddenly disappeared. Okay, now it came back. Okay, 4b minus 2a is equal to 1, and minus 2b minus 4a is equal to 0. Two equations, two unknowns. Now, to me, the most obvious choice to eliminate is the b, because you got 1 plus 1 minus. You could easily eliminate the a2, but you're going to have to multiply this by a minus. So let's just multiply this one by 2. Okay? Multiply that second equation by 2. Okay? Now that gives us, first equation stays the same, 4b minus 2a is equal to 1. Second equation is now minus 4b minus 8a is equal to 0. Right? If you add those two equations together, you eliminate your b's. That gives you minus 10a is equal to 1, which implies that a is equal to minus 1/10. And let's see, yes, that works fine. Now, let's take that one and plug it in anywhere we want to. Do you prefer the first equation or second equation? Usually I avoid the two. Huh? I like the second one too. So before we multiply by 2, so I'm going to erase that 2 now. We've already used it. Okay, and erase that parentheses. And I'm going to rewrite this as 2b is equal to minus 4 times 1/10, or minus 1/10, right? So I moved 2b to the other side and made it positive, is equal to minus 4 times a, which is minus 1/10. So this will be b, I'm going to do a couple things at once here. B is equal to, I'm going to divide by 2, and that will give me positive 1/5. Do you agree? Okay. Now, oh my word, I did erase too much. My y particular is equal to, catch me if I'm right on this, I think it was a e to the x cosine x plus b e to the x sine x. I hope that's how I did it. Okay, so now we can plug in our a and b, and that would be negative 1/10 e to the x cosine x plus 1/5 e to the x sine x. Okay? Now, our overall solution, y, is yc plus yp, and that would be c1 plus c2x plus c3 e to the minus x minus 1/10 e to the x cosine x plus 1/5 e to the x sine. And there we have it. C1 plus C2x plus C3e to the minus x minus 1/10 e to the x cosine x plus 1/5 e to the x sine x. Fantastic. Fairly a lot of work though. But all the steps were pretty straightforward. I don't know why last time, I think I was just feeling so rotten. I was looking for A's and B's to be part of it too, and they're not, And so I should have been just isolating my variables and constants and as the coefficients and letting the function be the e to the x, trig function to the x. Okay. All right. Ready for 11? Yeah. Well, we hadn't started it. We had started this one, but we had, in the book, it's page 149. Very bottom of the page. Okay.
Oh, let me ask something about this.
Okay.
Your y to the fourth plus third derivative, can you factor that in where you wish, like you have m squared plus m equals 0 for the auxiliary equation? Can you do
that? Okay. You were breaking the fourth derivative into auxiliary equation. Okay, yeah. Yeah, let's start the problem and then we'll deal with that, okay? Okay, let me write it down first. That's the fourth derivative of y plus the third derivative of y is equal to 1 minus x squared e to the minus x. Okay. Now, auxiliary equation would then be what?
So can you factor the auxiliary equation of like m to the fourth plus m to the third is equal to 1 minus e?
No. Remember, the auxiliary equation only works for the homogeneous part. So you first take the left-hand side, the derivative side, and set it equal to 0. So it has to equal 0. You don't want that other mess in it because you'll never get it equal to 0 then.
Okay.
Yeah.
I'm just focused on saying.
Is that what you're asking?
Equal 0.
Yeah.
If you factor that fourth derivative, the third derivative, any value you wish.
I guess you
could. First, you want to factor that m squared plus m squared plus 1 is equal to 0.
Okay.
Because you could take m cubed on the outside and make that m plus 1. You're going to come up with a negative number there.
Okay. Well, I think I hear what you're saying, but you just keep factoring until you can't factor anymore. And the greatest monomial factor is m cubed, right? And what does that leave you with?
Just 1, m plus 1.
M plus 1 equals 0. Okay? Now we have a triple root of m. Okay? M equals 0. I'll write it down the way you were suggesting. 3 zeros there. And what's your last one? Minus 1. So that gives you, as your...
Okay, you're going to have C1 plus C2x.
Okay, yeah.
C3.
For some reason, this thing has quit charging again. I don't know why it does this. There, it's doing a little better now. Yeah, so y sub c is equal to C1
plus
C2x
plus I was going to step this up to 3.
C3x squared. Yeah. Those are your three you get from your 3 zeros. Plus C4 e to the minus x. Perfect, perfect. Now, all right. There's your complementary solution. Okay. Now let's go to the right-hand side so we can fiddle with our particular solution. So this leads to y sub p. What would be your first guess?
I'm just going to say e to the x.
Yeah, you're going to have to use some x's. But that first one is just a constant. Normally, you just say a, right? But guess what? We've already got a constant by itself down there with C1. So you can't do just a. So then you say a times x. But you already got a C2x, so you can't use that. Then you bump it up another notch, and you get a x squared. But you already got a C3x squared. So bump it up again, and you finally get a x to the fourth. Oh boy, that's where we're starting. Now, the next part. Normally, we just do a b. What would you do then?
X to the fourth man. Do like check that would be x to the fifth to the e raised to the
Okay.
x squared. Do I have that?
All right. Yeah. Let's see. Pause a moment here. Normally, we'd say the x squared would be something like bx squared plus cx plus d, or something like that, right? You'd have to do the polynomial that has all the powers below it. And then you do times e to the minus x.
You say you have to do all the polynomials.
Yeah. Yeah. If you go back to our infamous table there, 4.4.1, if you have a polynomial, look at 2 or 3 or 4, then the form of your y sub p, if you just had a constant, a is sufficient. If you have a linear, you do ax plus b. If you have a quadratic, you do ax squared plus bx plus c. You got to have every possibility. If you had a cubic, you do ax cubed plus bx squared plus cx plus e. They didn't show one with just a single term, but whatever the maximum exponent is, you have to account for every term below it. Now, some of those may wind up being zeros, and that'll be fine, but you have to assume you got them to begin with. Okay, so that part, the x squared, just the x squared, produces the bx squared plus cx plus d. Okay, and since it's multiplied by an e to the minus x, we just leave that e to the minus x. Okay, sort of like number 8 in your table. 9x minus 2, you'd have ax plus b times e to the 5x. Okay? Here you have a x squared, so you have to have a bx squared plus cx plus d, accounting for every term, times e to the minus x. But, Houston, we have a problem. We already have a C4 e to the minus x here, so that e to the minus x is, we can't handle it. So we got to bump the d up by 1, that would give a dx. Then do your c to be an x squared, and your b to be an x cubed, because you have to bump it up a notch. And here it is. We were hoping you would come. All right, good deal. We're doing, do you have to turn around and leave? Okay. Okay, well, it's up to you. I did it one time. Well, where has it gone? Oh, there it is. I'm not certain it has staples in it, but okay. Good deal. Thanks. You too.
You know, okay?
I'm doing pretty good. I said you stay straight.
Yeah.
Yeah, that's wrong. I ain't got to work a full schedule. I ain't just do, you know, 20 hours. I want to probably about 3 hours. I'll be trying to overwork. You know, I just had to work at 6 in the morning.
Oh,
It's cold. It's really cold.
yeah. All right.
Thanksgiving break.
All right. You have good Thanksgiving. All right. So you see, if you were to multiply this through distribute, which we're ultimately going to do, I just wrote it this way to see that for this part, and this is for that part. Then if you distribute that, it would be a bx squared e to the minus x plus cx e to the minus x plus d e to the minus x. But we already have a c4 e to the minus x. So that means we have to bump this up to an x, which means then we'd have two of them, so we have to bump this up to an x squared. But then we'd have two of those, we have to bump that up to an x cubed. Wow. They decided to really hit us with a case 2 here. Almost feel like they're hitting us with 2 cases. Okay. All right. So our particular solution with the, oh, whoa. I'm sorry. I let it off with B. I should have let it off with C. Sorry, we already had a B. So let me go back and revise that and make it a C, D, and E. But then each of those have to be bumped up by an extra X. So this will be a plus CX cubed e to the minus X plus DX squared e to the minus X plus E X e to the minus X. Okay. There's our particular solution. And we've got to raise that to 4 powers, 4 derivatives. What a joy. We're going to be writing for a while, okay? I'm going to go on and erase this because we're going to need all the room we can get, okay? So let's start by taking a derivative. Actually, the first few are pretty easy. Y prime, YP prime would be what? 4ax to the third. Wait, I've got to fight with my power cord again because my light's gone completely off. I don't know what this is doing. I think I've got it back on a little bit anyway. Okay. Next one. 0. Yeah, okay. All right, so the next one after that would be, second? Right. Plus 3cx squared e to the minus x, right? Okay. Now the second half of that product rule would be a minus cx cubed e to the minus x, right? Okay. Now, the first part of the next one would be a plus 2 dx e to the minus x.
I keep seeing it as a 4. I don't know why I think about a 4. It shouldn't be here.
Yeah, my x's sometimes look really bad. Okay. Plus, second half of that is dx squared. Yeah, it's a minus dx squared e to the minus x. I knew I was missing something there. Minus dx squared e to the minus x. And then the last one is plus e to the minus x minus ex e to the minus x. Oh my goodness gracious. All right. Let's see, is there anything we can combine here? I think not. Oh, wait. Yes, there is. These two x squared e to the minus x can go together. And these two x e to the minus x can go together. Okay, I think. All right, so let's see. I don't know if that's going to be helpful or not. Let's try it. That would be equal to 4ax cubed. That's really ugly. Okay. Plus, I'm going to put a parenthesis here, 3c minus d x squared e to the minus x minus c x cubed e to the minus x plus 2d minus e to the minus x plus e to the minus x. Wow. Okay. All right. Now let's take that and do a second derivative. Y double prime, y sub p double prime. Okay. First term. 12ax squared plus, now, yeah. Yeah, let me erase my parentheses because I forgot about my 2. Okay, yeah. 2, now let's go on and multiply it out, okay? Okay. Because otherwise, it's another step that I want to take, okay? 2 times 3c would be 6c minus 2d x e to the minus x. I don't know how that came out of minus 1. I don't know if I erased something or what. Okay. Okay. That's the first part of that product rule. The second part would be minus a 3c minus d x squared e to the minus x, right? There, I did it again, minus x. Correct?
I don't know because I can't see it.
Oh, I'm sorry. Okay. We started with this one, and you got that one perfectly. 12a x squared. Okay. Now this one was a product group. I'm going to do the one that's positive first. So that's 2 times 3 is 6c minus 2d x e to the minus x. You drop the 2 by 1. Okay. And then the other one is going to be a minus because of this one. So it's going to be a minus 3c minus d x squared e to the minus x. The first one is the same. You take the root of the second. That's something that's the minus sign. Okay. We're on this term here next. Cx cubed e to the minus x. That's a product rule. And that will be what?
Minus 3c x.
Okay, minus 3cx squared e to the minus x plus cx cubed e to the minus x. I did it again. Yeah. Okay. Now, this one with the constant only in front of e to the minus x will just be, it would be a minus, but I'm going to make it a plus and flip the sides of the signs there. Make that an e minus 2d e to the minus x, because there is no x term to multiply it. So there's just that. Is that okay? I kind of sleight of hand there. Okay? And then the last one was, I left off my x. There it is. Okay. It's another product rule one, but that's going to be a plus e to the minus x minus an x e to the minus x. All right. There's my y double prime. I think I'm going to start over here on the left and do my y double prime, see if we can combine some like terms. There's only one x squared term, so that's going to stay 12a x squared. Okay? Now, here's an x e to the minus x. And we got at the very end an x e to the minus x. So we can combine those two together to be a plus 6c minus 2d minus e x e to the minus x. All right, so we're taking care of that one, and this one. All right. Do we have any x squared e to the minus x? Yeah, two right next to each other. So what does that give us? That's a minus 3c plus d, if we take out the minus sign, with another minus 3. So that's going to be, if it's all right, I'm going to move the d in front. So I'm going to do a plus d minus 6c e goodness gracious. If I don't look exactly where I'm writing, it does all sorts of strange things. Okay. D minus 6e. No, that's not it. No, c. It's d minus 6c x squared e to the minus x. Okay? So that takes care of those two terms. Here we have x cubed e to the minus x. That's not met with anything, so that's going to be a plus cx cubed e to the minus x. And then we have 2 with e to the minus x in them, and that does look exactly like plus 2e minus 2d e to the minus x. SRY double prime. Well, I got 2 more to go before I start combining them. Y triple prime of the particular function is
Well, I know I could do more with that 24AX.
yeah 24ax. All right, plus
6. Oh, let's see. 6. That must be times X.
okay a 6c minus 2d minus e times e to the minus x, right? And then we'll have a minus 6c minus 2d minus e, yuck, e to the minus x. Okay, did I do that right? I think so. All right. Goodness gracious, I'm tired of this problem. All right, let's do the next one. Plus d minus 6c. There should be a 2 in front of that. Let's go on and multiply inside the parentheses too. Otherwise, I will get them forever lost. Okay. That's a 2d minus 12c times x squared. Goodness gracious. E to the minus x. No. That's x, not x squared. Okay. All right. Now we're going to do the second half of that one, which would be minus d minus 6c x squared e to the minus x. Okay. See, that takes care of this one, that one, that one, all right. Okay, I think we're ready for this one. This will be a plus 3c x squared e to the minus x minus goodness, I'm about to lose it. I just can't focus. Oh, there I am. I couldn't find where I was. Okay. Minus cx cubed e to the minus x. Okay, that's taking care of that one. Oh, wait, no. Yeah. Okay. I think this is the last one for this one. And that would be, I'm going to put I'll put a 2 beneath it. Never mind. Yuck. Get out of there. Okay. That's just going to be a minus 2e minus 2d e to the minus x. Nothing's going to change with that except that minus on that. That's all, I think. So that's done. All right, let's see if we can combine those terms. My goodness, this is a long problem. Okay.
Back up with the first two after 24a, I think we got a plus 6c minus 2b minus e to the minus x at plus 6c. Take with the first two terms up there.
Okay.
Second, third term.
All right.
After 24a.
All right. Oh, it feels good to stand up. I wish I'd have done this sooner. You should have asked a question earlier. So that one is okay.
Okay.
All right.
Next two.
Now, the next two come from this one. The first one is derivative of the first part, which that to the first power, that's just going to be 2 or 6c minus 2d minus e times e to the minus x.
Okay.
And then it'll be this one. Whoops, I left off an x. I left off an x there, sorry. You're right, that should be an x right there. Yeah. Because when you take the first times the root of the second, that's where the minus sign comes from. So yeah, that needed an x in it. Let's see if I've done that anywhere else. This one would be 2 times this, so I'm going to multiply it out. 2d minus 12c x e to the minus x. And then the second part of that is the d minus d minus 6c x squared e to the minus x. The minus times that sign. Okay? And then that single term there just became 3c x squared e to the minus x. That's the first part derivative minus cx cubed e to the minus x. So that has these two parts. And then this part, this is just a constant times e to the minus x. So that's just going to be minus that constant by e to the minus x. Okay. Now we got to see if we can combine anything. And oh my goodness. The 24ax stands alone, so we'll write it down. 24ax. All right. Now this is a term with just e to the minus x in it. And I have this one. And this one. Two terms of that. So we got to combine all these together. So that's going to be a plus 6c. You got a minus 2d here and a plus 2d there, so those are going to disappear. And you got a minus e here and a minus 2e there, so that'll be minus 3e e to the minus x. Okay, so we've taken care of that one. We've taken care of this one and that one. Okay, now we need terms with x e to the minus x. Well, here's two right next to each other. So what I think I'm going to do is make a plus here. Okay, and this minus 2d is going to be plus 2d is 4d And minus 6c minus 12c is minus 18c times x e to the minus x. I hope. Goodness gracious, this is getting rotten. Okay, that's taking care of those two terms. Okay? Now, we've got an x squared here and an x squared there. So let's combine those two. Well, that's going to be a plus 6c, and this is a plus 3c. So we'll make this a plus 9c minus d x squared e to the minus x. Okay? That takes care of those two. And then I think we only got one x cubed term, so it's minus c x cubed e to the minus x. There's our y triple prime. Just the last one. The fourth derivative of y, p. Okay? And this is just going to be a 24a, right? All right. Now, this one doesn't have an x in it, so that's just going to change the sign. There'll be a minus. Let me just make it a plus. Let's make it 3e minus 6c e to the minus x. Because that derivative just negates it, and I negated it. All right, the next one is going to have plus 4d minus 18c e to the minus x minus 4d, I can't write, minus 18c x e to the minus x. Goodness gracious, yuck. Okay, I've taken care of this one, taking care of that one, and I just took care of that one with two terms. All right, I'm going to double now, so that's going to be a plus. 2 times 9 would be 18c minus 2d, and this pen is messing up on me, and it's making me make right over, huh?
We doing the derivative of 9c.
Okay, yeah. Hold off, let me get my pen back. Okay, now let's see, where are we? Yeah, we're doing the derivative of this. We're going to do the derivative of this times that, so that's going to be 2 times this, which is good. Now, I had a c there, and then it disappeared, because there's a blank for it. So the 2 times this will be 2c minus 2, 18c minus 2d, and that would be x e to the minus x. All right, now we got to do the second part of that, which is going to be a minus 9c minus d x squared e to the minus x. Okay, we've taken care of that one. And then this last term is going to be, I'm going to do the e to the minus x first. So I'm going to do a plus cx cubed e to the minus x minus c 3 cx squared e to the minus x. Okay. Now, I have no more room to write. Now, I'm going to need my particular solution, so I don't want to erase it like I did last time. Okay? I don't need my y prime, because if I have to go back and figure out an error, I'm going to be in bad shape anyway. I'll just give it up and say I'll leave this to the student. Isn't that what they always say? Okay.
The most casual observer can always figure this out.
What's that again?
And the most casual observer can always figure this out.
Yeah. Yes, exactly. Oh, that is really, or it's intuitively obvious that. Okay, and I'll even wipe out my y double prime because I don't need that either. I need my y triple prime, but not the y double prime. I think I need another cough drop too, but I'm going to try to finish. They're not really cough drops, but ginger candy. And I'll wipe out this y double prime too. That way, maybe it'll be easier to see. At the end. No guarantee though. Okay. Now let's do our combining of like terms for y, the fourth derivative of yp. 24a, that's the only constant term we have. So that's gone. Now,
B minus 6c, that's the e to the x term, plus b minus 18c e to the x, that's was 5.
okay,
Yeah, c.
things that have just e to the minus x are those next two. So that's going to be, I'm going to sort of put them back in order. 4d plus, minus 18c. Wait. We have a minus 18c and a minus 6c, so that's a minus 24c, isn't it?
Yeah.
(24c). Okay, plus 3e. And that's going to be times e to the minus x. What's that?
You said 3e or 3b?
I think it's a 3e from this one. Okay. This one became a 4d.
Yeah, that's right.
Yeah, 4d. And then we have minus 24c plus 3e. And that took care of those two.
My bad, I wrote it incorrectly.
Yeah. All right. Now those were just x's in them. These are almost lining up properly. Okay. Let's start off with we have a plus 18c here and a plus 18c there. So that's going to be a plus 36c. And then we have a minus 4d and a minus 2d, so that's minus 6d times x e to the minus x. Okay? So that took care of those two fairly easily. Now let's do our x squared terms. We got minus 9 and a minus 3 is a minus 12 and a plus 1d. So I'm going to start with the d. d minus 12c x squared e to the minus x. Okay, and then that takes care of those two, and then we just have a plus c x cubed e to the minus x. All right. Now, what we've got to do is write the equation, and I think we're just about out of time. Oh, in fact, no, we're not quite. Let's see if we can. Okay, so the fourth derivative of y particular is 24a plus 4d minus 24c plus 3e e to the minus x plus 36c minus 6d x e to the minus x plus, I hope that's a plus, okay, I didn't write it, but plus d minus 12c x squared e to the minus x plus c x cubed e to the minus x. All right. We're going to take that one and add to it the thing we've got down here. And unfortunately, I drew lines through it. So I'm going to remove some of my lines. That one, and that one, and that one, and that one. Okay. There's my YP triple prime. Okay. It's another 24, it's a 24AX. Okay, plus a 6c minus 3e e to the minus x plus a 4d minus 18c x e to the minus x plus 9c minus d x squared e to the minus x minus cx cubed e to the minus x. My word, look at this. Those two disappear, which is kind of good because we didn't have any x cubed e to the minus x's anyway. So that's excellent. Okay. Now I need more room, but we need more time too. So afraid we're going to have to end it here. Do you think?
But if we end it, can we start it,
You know what they did? Do you know what they did? They didn't work this out to completion.
well, they skipped everything.
They said determine the form of the particular solution, and that's all they wanted, and that's what I have at the very top line. It's y sub p is equal to ax to the third. Where did I get a fourth? Plus,
let's step it up for an X. And then
Yeah.
if we want to step it up here, and then we already had an X.
Yeah.
And we couldn't use the minus X of it, so we go to X squared.
Yeah.
And then we have to go, yeah, then we have minus one. We have to move from minus one.
Okay, they started with a plus bx squared okay. I think I see what they did, sort of. Okay, they bumped each of the last three up. I can see that. Each of the x, okay, starting from the back and working forward. They skipped the D there, but that works out. But then oh wait. See. Oh. No, I did it right. So our complementary solution is correct. And then the other, it shouldn't start at x to the fourth, it should start at x cubed. I don't know where I got the fourth there. Yeah, that's the x cubed. That's the only place I think I messed up. That's, well, maybe one other place. Let me see. That's x cubed. Okay. Now, and that's all you need. There's not a b there. The b doesn't make any sense there. So I don't know why I came up with that. Because you see, you already have a constant down here. The b wouldn't make any sense. So that this would have been an x. No, this would have been an a, but we already had a constant. Then we bumped it up to ax, but we already had a cx. Then we bumped it up to ax squared. We already had that. So we bumped it up to ax cubed. And that's all. I don't know where the b came from. Okay? So with that correction, and I don't even know where it came from, then I'm going to, they did bx cubed well, I was doing all that work, and all they were asking for was a particular solution. And they did a cx squared. I'll just change it to make it look like theirs. Okay. Yeah. And then they skipped the D, so they went to E. That's all they wanted. I am so sorry. But you see, this could really turn into a monster. It did. I just wasn't paying attention. That's all they wanted was a particular solution. I just assumed they wanted a general solution. I didn't even read the problem. I just looked at the equation. Sorry about that. We spent a lot of time doing that. But it wasn't all wasted, I don't think. Homework exercise, any of the odds 1 through 25 that are in the back, any of the odds 27 through 35 that are in the back, either 37 or 39 if they're in the back, and 41 if it's in the back. Now, if you find any of the discussion problems in the back, odd ones, you can do those too. We're not going to do 4.5. We've already done superposition. You do either superposition or annihilator. We did superposition. So let's skip 4.5. We'll pick up 4.6 Tuesday after Monday after Thanksgiving, right? Yeah. All right. So we'll begin in 4.6 there. I'm sorry. I didn't read the problem. That took an enormous amount of time, but I don't think it was all wasted. You see how complicated these can be. Now, of course, I had some bad things in there, like a to the fourth, that I don't know where that came from. But anyway, that would have changed everything down below, so don't sweat that at all. Yeah.
We're not gonna do 4.5.
Yeah, we're not doing 4.5. You either do 4.4 or 4.5. You don't need to do them both. The note on page 142, note to the instructor, in this section, the method of undetermined coefficient is developed from viewpoint blah, blah, blah. In section 4.5, an entirely different approach will be presented, one utilizing differential annihilator. Take your pick. We picked 4.4. So we're not going to do 4.5. Okay? I've done 4.5 before, and usually students act like they don't understand that. I had a class and a guy said, "Oh, that sounds like fun. Let's do that one." I said, "Okay, let's do that one." After that, he said, "I wish I would have done superposition." So we'll start with 4.6, variation parameters, Monday after Thanksgiving. We almost went to our regular stop time. Let me get this